I've now talked about taking the Laplace transform as well as the inverse transform, so let's try to solve an initial value problem from start to finish. Here I have y double prime minus 2y prime plus 5y equal to 8 e to the minus t. We know y of 0 is 2 and y prime of 0 is 12. I'm going to start by assuming the transform of y is capital Y of s. This tells me that the transform of y prime is s times capital Y of s minus y of 0. And the transform of y double prime is then s squared y of s minus 2s minus y prime of 0, which is 12. We also have that the transform of 8e to the minus t, according to our table, is 8 over s minus a, so s plus 1. So I'm going to rewrite my equation. Y double prime is s squared capital Y minus 2s minus 12. I then have minus 2y prime, so minus 2s capital Y plus 4 plus 5 times capital Y for the 5y. And then that should be equal to 8 over s plus 1. We can then rewrite this left-hand side, so I have s squared minus 2s plus 5 times capital Y minus 2s, and then I have a negative 12 plus 4, so minus 8. This is equal to 8 over s plus 1. I'm going to go ahead and add 2s and 8 to both sides. That gives me s squared minus 2s plus 5 times capital Y is equal to 8 over s plus 1 plus 2s plus 8. And we're actually going to want to write this right-hand side as a single fraction. So this is 8 over s plus 1. I need a common denominator of s plus 1. So the top will be 2s plus 8 times s plus 1. That gives me s squared minus 2s plus 5 times capital Y. And if I multiply out this right-hand side and simplify it, we get 2s squared plus 10s plus 16 over s plus 1. We can then divide both sides, and I get y is equal to 2s squared plus 10s plus 16 over s plus 1 s squared minus 2s plus 5. And now we need to look at taking the inverse transform, and that's going to require a little bit of work. Let's start with the s squared minus 2s plus 5. This can't be factored, so we want to write this as s minus a squared plus b squared. That tells me I have s squared minus 2s plus 5 is equal to s squared minus 2as plus a squared plus b squared. Coefficients of s are negative 2 and negative 2a, so I have that a is 1. My constants are 5 on the left and a squared plus b squared on the right. I know that a is 1, so that gives me that 4 is equal to b squared. So I'm going to rewrite this. 2s plus 10s plus 16 over s plus 1 times s minus 1 squared plus 4. And now I need to do my partial fractions. I'm going to have an a over s plus 1. The fact that this is a quadratic term means I'm going to need a term that says b times s minus 1 over s minus 1 squared plus 4. I also am going to need a 2c since b is 2 over s minus 1 squared plus 4. Multiplying by our denominator gives us 2s plus 10s plus 16 is equal to a times s minus 1 squared plus 4 plus b s minus 1 s plus 1 plus 2c times s plus 1. So we need to solve this. I'm going to start by letting s be equal to negative 1. On the left-hand side, that gives us, we missed a squared here. As I let s be negative 1 on the left-hand side, I'm going to have 2 minus 10 plus 16. On the right-hand side, negative 1 minus 1 is negative 2. Squared is 4. Plus 4 is 8, so I have 8a. This term and this term will be 0. So I have 8 is equal to 8a, or a is equal to 1. There's nothing I can pick to make any of the others, or 2 of the other 3 cancel. So I'm going to expand this out. When I do, I get as squared minus 2as plus a plus 4a plus bs squared minus b plus 2cs plus 2c. My coefficients of s give me that 2 is equal to a plus b. I already know that a is 1, so that tells me that b is also equal to 1. Looking at my coefficients of s, I have 10 is equal to minus 2a plus 2c. Once again, we already know that a is 1. We can add 2 to get 12. And so c is equal to 6. So now I have all 3, and I can go ahead and rewrite this the way I originally had it, which says that capital Y of s is equal to a over s plus 1 plus b times s minus 1 over s minus 1 squared plus b squared, which was 4, plus c times 2 over s minus 1 squared plus 4. Now we just need to take the inverse transform of this. The inverse transform of 1 over s plus 1, according to our table, is going to be e to the minus t. This term here is going to be e to the t, since a is 1, and then cosine of 2t, which comes from the 4. Here I have 6 times, once again, e to the t, since I have s minus 1, times sine of 2t. So now I have the full solution to my initial value problem. Let's do one more. Once again, I'm going to let the inverse the transform of little y be equal to capital Y of s. The transform of the first derivative is then s times capital Y minus y of 0. And the second derivative will then be s squared capital Y minus s times this, minus y prime of 0, which is 0. In addition, I need to transform t e to the t. And according to my table, this is 1 over s minus 1 squared. When I rewrite, I have y double prime plus 4y prime, so that gives me plus 4sy minus 4 minus 5y is equal to the transform of t e to the t, which is 1 over s minus 1 squared. Rewriting gives me s squared plus 4s minus 5 times capital Y minus s minus 4 is equal to 1 over s minus 1 squared. I can add s and 4 to both sides. That gives me s squared plus 4s minus 5 times y equal to 1 over s minus 1 squared plus s plus 4. I need to go ahead and combine this into one fraction. So this is 1 over s minus 1 squared. Plus, we need the common denominator of s minus 1 squared. So the top is going to be s plus 4 times s minus 1 squared. And so we have s squared plus 4s minus 5y. And once we multiply out and simplify the right-hand side, we get s cubed plus 2s squared plus 7s plus 5 over s minus 1 squared. And then we can divide. We get capital Y is s cubed plus 2s squared plus 7s plus 5 over s minus 1 squared times s squared plus 4s minus 5. And now we need to do our partial fractions. So I'm going to rewrite this. I'm going to start by realizing the denominator can be fully factored. So I'm going to go ahead and factor it. When we do, this factors into s plus 5, s minus 1. So I actually have an s minus 1 cubed. So on the right-hand side, I need an a over s minus 1, a b over s minus 1 squared, and a c over s minus 1 cubed. And then we also have a term over s plus 5. As we multiply this out, we get x cubed plus 2s squared plus 7s plus 5 is equal to a times s minus 1 squared, s plus 5, plus b times s minus 1, s plus 5, plus c times s plus 5, and then d times s minus 1 cubed. And we're going to start by letting s be equal to negative 5. Negative 5 cubed is negative 125. Negative 5 squared is 25 times 2 is 50. 7 times negative 5 is minus 35 plus 5. On the right-hand side, the a, b, and c terms all cancel. Over here, I have negative 5 minus 1 is negative 6. Cubed is negative 216d. So this gives me minus 105 is equal to negative 216d, which gives me 35 over 72 for d. The next thing I'm going to do is let s be equal to 1. Then I have 1 plus 2 plus 7 plus 5. On the right-hand side, the a, b, and d terms cancel. 1 plus 5 is 6, so I have 6c. This gives me 15 equal to 6c, or c is equal to 5 over 2. Using that, I'm now going to multiply this right-hand side out. S cubed plus 2s squared plus 7s plus 5 is equal to a s cubed plus 3as squared minus 9as plus 5a. The b term becomes bs squared plus 4b minus 4s minus 5b plus cs plus 5c. And then my d term becomes ds cubed minus 3ds squared plus 3ds minus d. From there, I'm going to look at my cubed terms. I have that 1 is equal to a plus d. I already know what d is. And that gives me that a is 37 over 72. I'm now going to look at my s squared terms. The left-hand side has a 2. The right-hand side has 3a plus b minus 3d. I already know what both a and d are. So this gives me 111 over 72 plus b minus 105 over 72, which simplifies to b being 23 over 12. So now that we have all of that, we can rewrite. We had capital Y was equal to a 1 over s minus 1. We then had b times 1 over s minus 1 squared, c times 1 over s minus 1 cubed, plus d times 1 over s plus 5. We can now look at using our table to actually transform this. This would be 37 over 72 times e to the t. The next one, 23 over 12 times t e to the t. This next one would be 5 over 4 times t squared e to the t. So the 4 balancing out the fact that I do need a 2 here in the numerator. And then finally 35 over 72 times e to the minus 5t. And I have my solution.